Okay, we're back. Let's go ahead and work through this 13.4 scientific notation. So in real life, many applications in the real life, numbers are either really, really big or really, really small. And so what we do is we try and have a notation that allows us to write very, very big or small numbers in a kind of nice, easy, clean, condensed way. So before we can begin, we need to define something and be clear on what it means. So we already saw what something like b to the n means. That meant b times b times b, and we do that n of these, right? We've already seen that. But now we're going to look at what does b to the negative n mean. So what happens if you have a negative exponent on a base? And so by definition, what this is, and this is all written down to the left here, but what this means is that you can rewrite this as 1 over b to the positive n. You may have heard this before, that if you have a negative exponent, you just drop it down to the denominator. So let me give you a more concrete example. Let's say we have 4 to the negative 2. What this really means is 1 over 4 squared, so it becomes positive. And of course, that means 1 over 4 times 4, which is just 1 over 16. So 4 to the negative 2 is the same as 1/16. So we're going to use this as we move on in this section, that anytime we see a negative exponent, we need to realize that it means 1 over that to a positive exponent. Now, on the other hand, if you start off with something that has 1 over b to a negative power, then you can move the b up this time and put it on top and make it positive. So look at that as like a fraction. So again, if you start with a base raised to a negative power, you drop it down to make it positive. If you start with the base to a negative power on the bottom, you move it up and make it positive exponent. Okay, so here are a couple of examples. If you have 10 to the negative 5, since you have a negative exponent, you move it up to the top, it becomes 10 to the positive 5. Here, if you have 10 to the 9, then you could move it up and make it 10 to the negative 9, or you could also look at it this way. If you start here, you would drop it down. So it works both ways. I think you'll see as we continue to move on with this how we're going to use this. Now, what is scientific notation? Scientific notation is anytime we express a number in the form of a number, a, times 10 to some power of n, and it's always base 10 here to the power of n. So here's some examples underneath. If we take the number 6,000, what we can do is we can imagine that that's the number 6 times the number 1,000. But 1,000 is 10 times 10 times 10, which is 10 cubed. So we could rewrite this as the 6 times 10 cubed. So that is equivalent to saying the number 6,000. Another one here, if we have 0.0002, remember that this, when we were doing place values a while back, this would be the same as 2 over, we would count the places, tenths, hundredths, thousandths, 10,000, so that would be 10,000 on the bottom. Okay, now that's the same as 2 times 1 over 10,000. But then that's the same as 2 times 1 over 10,000 is really 10 to the 4th power. So if you want to get 10,000, you can just multiply 10 times itself 4 times. And now this right here should look like notation that we just worked with. That should be 2 times, I can bring that 10 to the 4 up and make it negative 4. So this is the scientific notation for this decimal. Now, let's kind of see how we can do this a little easier rather than having to do all this work in here. If we go back to 6,000, let's just start over here. If we go back to 6,000 and we want to write this in scientific notation, what we do is we identify the decimal. So here's the decimal. And what we want to try and do is rewrite this as a number. So in this case, the only number we have here is 6. We want to rewrite this as 6 times 10 to some power, okay? And to determine that power, what we're going to do is count how many decimal places we have to move to get the decimal point right behind the 6. So 1, 2, 3. We want to go 3 places to the left. So we go 3 left. And anytime we go left, we want to do a positive number. So left means positive. So that means I'm going to put a positive 3 up here. I'm going to erase the box. Positive 3. Let's look at the example below. We had 0.0002. We want to convert that into, let's see, the only number we have there is 2 times 10 to some power. This time we're going to move our decimal point 1, 2, 3, 4 places to the right. So we went 4 to the right, and anytime you go right, you're going to be using a negative exponent. So we went 4 places to the right, so minus 4 we put up here. And notice that those answers match what we had before. 6 times 10 to the third, 6 times 10 to the third, and then this one was 2 times 10 to the negative 4, and we got 2 times 10 to the negative 4. So this is all really going to just break down into moving decimals and counting and determining whether or not we're going left or right. Okay, let's do a couple of examples. Okay, so let's take a look at this number here. This big old nasty, well, it's actually a very small number, but it's got a lot of decimals. So what we're going to do is we're going to try and move our decimal point to right behind that 8. Right behind that 8. Right there. So we got to count how many places. 1, 2, 3, 4, 5, 6, 7. We have to move it 8 places. And we're going to go 8 places to the right. And when we go to the right, this is going to be a negative number. Okay, so what we'll do is we'll write 8.43 because we moved the decimal point, right? We moved it right there. So we're going to write that number 8.43, and then we're going to put times 10. And then we moved 8 places to the right, so we're going to put an 8 here, and because we went to the right, we're going to make it negative. Okay, let's try the next one. So here, our decimal point is right here behind the 0, and we want to try and move it to right there behind, I keep doing that, right behind the 4 right there. So we're going to move our decimal point, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We're going to go 8 left, and left will mean positive for us. So we're going to write the number 4.56, we're going to get rid of all the zeros, times 10, and then we moved it 8 places to the left, so we're just going to put positive 8 up there. So these are the scientific notations for those numbers. So a very big number can be written this way, a very small number can be written this way. So the main thing that shows you the difference between a big number and a small number is whether or not this is negative or positive. If you have a positive, think big number. If you have negative, think small. Okay, so here's something to work on. Total combined salaries of the president, vice president, senators, and representatives of the U.S. federal government is approximately $85 million. So we're going to write that in scientific notation. Here's our decimal place. We're going to move it to right behind the 8. So we always want to have just a single digit in front. Okay, so we know it's going to be 8.5 times 10, and we're going to be moving this 1, 2, 3, 4, 5, 6, 7 places to the left, and left means positive, so we're going to have 8.5 times 10 to the 7th. And this is money, right? So that's how much. All right, the length of the shortest wavelength visible light is this, meters. So we're going to move our decimal point to behind the 4. So 1, 2, 3, 4, 5, 6, 7 places to the right. So we're going to have 4 times 10, and we went 7 to the right, so right means negative. So negative 7, 4 times 10 to the negative 7th. Okay, now we can go the other way. Okay, this time, if we're given a number in scientific notation, we can convert it to the standard form. So in this one right here, we know, first of all, this is a small number because it's negative exponent. So to change it back to a decimal, what we're going to do is we're going to take the 5.41 and we're going to move our decimal point 5 places to the left. 1, 2, 3, 4, 5. We're going to place it right here. We're going to put zeros in here. And remember, the decimal point went away, so it's no longer there. So we get 0.0000541. Okay, on the next one, we have a positive exponent. And so we know this is a big number, so we're going to take our 8.063 and we're going to move our decimal point 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. We're going to put 0, 0, 1, 2, 3, 4, 5 zeros. So we should get 8, 0, 6, 3, and then that's what, 5 zeros? 1, 2, 3, 4, 5. Put some commas in here. So we got 806 million is that number. Okay, so these group work says convert the scientific notation standard form. So for this one, we're going to take our 2.62. We're going to move our, this is a big number, so we're going to move our decimals to the right. 5, 1, 2, 3, 4, 5. Put zeros there. So we get 262,000 there. Okay, so 262,000 square miles. Okay, now this one is a small number because it's negative, so we're going to put 3.94, move it 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, right there. 0, 0, 0, 0, 0, 0, 0. Get rid of the decimal here. That's our decimal in standard form. Okay, so how do we go about multiplying numbers that are scientific? So this is what makes scientific notation nice. What if we have this number here, which is a very small number because we have a negative exponent, times a very big number? Well, all you have to do first, get your calculator out, all you have to do is first take the two numbers in front and multiply those. So 2 times 3, that would give us 6. And then we're going to say times 10, and then this is the cool part. Really what we're doing is we're taking this 10 to the negative 7, and we're multiplying it times 10 to the 13th, and we already learned this. If they have the same, if they have the same base and they're multiplying, all we do is add those numbers together, right? So what's negative 7 plus 13? That's going to give you 6. So this is going to be 6 times 10 to the 6th. And of course we could convert that to standard form, but we're going to leave it in scientific notation. Okay, take a look at this one. We have this number and this number. We get on our calculator, 5.9 times 3.6. That's going to give us 21.24. Then we're going to do our bases, 10. We have exponents, negative 3, negative 5. Let's add those up. That should give you times 10 to the negative 8, because negative 3 plus negative 5 is negative 8. Now, we look like we're done, but check this out. Our decimal point is not right next to the 2. We need that decimal point to move over one place this way, right? So what we're going to do is move it over one place, 2.124 times 10, right? Now the question is, what happens to this power here? So we moved our decimal point over. Maybe I should give you an example that would make a little more, hopefully make a little more sense. What if I had 10.0 times 10 to the negative 8? Okay, so think of it this way. This 10 is really like a 1 times 10, and then times 10 to the negative 8. So there's really like a 1 up there, and if I put those together, that's going to give me a negative 7. So moving the decimal point over means you're going to add 1 to this exponent. So what I'm going to do here is I'm going to take that negative 8, and it's going to become a negative 7 instead. So kind of a tricky point there, but I hope that that makes sense, that by moving the decimal place to the left once, you're going to add 1 to that exponent, whatever it is. All right, so these, let's multiply these. We're going to do scientific notation. So first thing I'm going to do is I'm going to rewrite this as 3 times 10. Let's see. This is a small number, so 1, 2, 3, 4, 5, 6. So negative 6 times this one. My decimal points here is a big number. 1, 2, 3, 4, 5. I move it there, so 2 times 10 to the 5. Now I multiply 3 times 2. That gives me 6. And then I add these exponents, and that gives me times 10 to the negative 1. That's a little tricky. Okay, next one. This can be a little easier. I'm just going to multiply these on my calculator. Well, this might not be so easy. 9.75 times 8.06. That gives me 78. 0.585. And then we're going to do these two together. We add the exponents. We put times 10 to the negative 4. But again, remember, we need to move this decimal place 1 to the left. And that means we're going to add 1 to this number, and adding 1 to that gives me negative 3. Okay, so that's multiplying numbers in scientific notation. How do we divide? Well, division works really nice. You're going to take these two numbers and divide them on your calculator. So 9.5 divided by 1.9, that gives me 5. And then when I do this, they have the same base, and they have different exponents, but we're dividing. So remember, we learned that that means you subtract. So we're going to go times 10. We can do 11, take away 3, you get 8. And that's it, we're done. This one, same thing. We're going to do division here. So 2.72 divided by 6.8. That gives me 0.4 times 10. Now this one's a little tricky because we have to take negative 6 and subtract from it this one, which is negative 4. So be real careful here. This is negative 6 plus 4. That gives you negative 2. Now, this is not correct yet because we don't have a number by itself with a decimal behind it. We actually need to move this decimal point this time to the right. So we're going to go we'll just put 0 times 10. Now, what do you think happens to the exponent? Remember, when we did this problem before, in the previous example, when we moved our decimal point 1 to the left, we added 1 to this. So what happens, do you think, what happens if you move it 1 to the right? Well, you're going to subtract 1. So we're going to take negative 2, and we're going to subtract 1 from it. That gives us negative 3. Okay. I'm going to let you work those yourself and see if you can't work them out. And if you have questions, then we can talk about it when we meet on Zoom. All right. Hope this helps.